Hello everyone, welcome back to my YouTube channel. Today we are going to study crystallographic points and how to annotate them. So when we are dealing with any crystalline material, it becomes necessary to specify the points that lie within the unit cell for certain purposes. So for this purpose, certain labeling conventions have been established in which three numbers or indices are used to designate points. So, to specify the point, a three-number system is used where the numbers are written as Q, R, S. They are not separated by commas or enclosed in any kind of braces. Okay, so to find out the coordinates, it is necessary to establish a coordinate system. It is necessary to establish a coordinate system that has it is necessary to establish a coordinate system that has a right-handed nature. So this can be so the coordinate axis can look like this will be your x, this will be your y, and this will be your z. So this will be the coordinate system that needs to be established before determining the points. Okay, so these 3 points can be used. So now what are these three, q, r, and s? So basically they are the fractional multiples or fractional lengths of the point along the three coordinate axes respectively. Okay, so q is the fractional length along x, r is the fractional length along y, and s is the fractional length along z. So qa is the point along x, rb is the point along y, and sc is the point along z, where A, B, C, they are the unit cell edge lengths along X, Y, and Z respectively. Okay, so now if we have this parallelopiped kind of a unit cell, so if this is our unit cell, okay, so what will be our axis as established by the right hand coordinate axis convention? This will be our X, this will be our Y, and this will be our Z. So as per that, this edge length will be A. So I'll mark it here. This edge length will be A. This will be B. and this height will be C. So now suppose your point lies somewhere here. Okay, so upon projecting it is like this. So this particular is the fractional length or the point along x. So this is your QA. So this length is your point along y. So this will be RB, and this is along z. So this will be SC. So this particular point P can be denoted by QRS, which are the fractional multiples or fractional lengths along this x, y, and z. So for example, let us mark the points of a face-centered unit cell. Example. So this is a unit cell. So the points we have okay, so these are the points that we have. Okay, so let us mark these points number by number. So we can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So starting with 1, we have to find the fractions of the length along the x, y, and z axis. So we can make a table where we have this point number Q, R, and S. So for example, for point 1, it lies at the origin. If this is our axis, so all the fractions, so point coordinates are, so let us introduce one column of coordinates as well. So point number 1, it lies at the origin, so its coordinates will be 0, 0, 0. These are the coordinates. So these points, these fractions will also be 0. So for point 2, coordinates are Q, R, and S. So this will be, so these, it can be like the coordinate value is equals to Q into edge length. So here edge lengths we consider as unity, all the three. So these become equal to the coordinates. Okay, otherwise what you have to do is Q is equals to coordinate x coordinate divided by A, that is edge length along x. R is equals to y coordinate divided by B, and for S, C coordinate divided by C. So this will be now 1, 0, 0, 0.3. It cuts x and y at 1. So it will be 1, 1, 0. Okay. 0.4 is 0, 1, 0. So it will be 0, 1, 0, 5. This one, it cuts x at 0. It isn't cutting x, it lies in the yz plane. Cuts y and z at 1 So 0, 1, 1. So it will be 0, 1, 1. So for point 6, it cuts all the three coordinate axes at 1. So it will be 1, 1, 1. Point 7, this lies in the xz plane. So it will be 1, 0, 1. So point 8, this lies on the z-axis. So it is 0, 0, 1. 0, 0, 1. 9 lies on the face center. Now 9 point cuts x at half, y at half, but z at 1. So half, half, 1. Point number 10, it cuts x and y at half each, but doesn't cut z. It will be half, half, 0. Point 11, it lies in the xz plane and doesn't cut y-axis. It is a face center, so half, 0, half. So these fractions will also be half, 0, half. Point 12, this lies here, so it cuts y at 1 and x and z at half. So it cuts y at 1 and x and z at half. So this is half, 1, half. Point 13, it lies in the yz plane, so it is 0, half, half. So 0, half, half. Point 14, so it cuts x at 1 and other two at half and half. So 1, half, half. 1, half, half. Point. So we have a total of 14. So these are the Q, R and S values for a FCC system. Okay. Thank you all. So this is how we can define the various crystallographic points of a unit cell. Thank you. We'll cover crystallographic directions and planes in further videos.